I'm Anil Kumar, and now let us explore the definition of slopes of lines. A line segment has one endpoint of a 3, minus 1 and slope of 3 over 4. Find the coordinates of another possible endpoint b. It is a very interesting question, and it will really help us to understand what slope really is. So what we are given here is one endpoint of a segment. Let's say this is our segment, right? So what we are given here is one endpoint of the segment A, which is 3 minus 1. And we need to find the other one, which is B. We don't know what the coordinates are, right? But what we are also given here is, we are also given that slope is given to us as 3 over 4, right? So we are given slope, and we are given point A, whose coordinates are 3 minus 1. And we need to find the coordinates of point B, right? How are you going to find it? Well, let's start from the very basic definition of slope. Slope of a line is the ratio of change along the y-axis to the change along the x-axis between the 2 points. That is to say that slope m is actually equals to, let me see what is the change here. So let's draw a triangle. So change along the y-axis. So this is the y-axis, vertical, right? So that is delta y. So it is delta y, change along y-axis, and change along the x-axis. So this is delta x. So that is delta x. That is slope for us. So to get to the next point, which is away, delta x units horizontally and delta y units vertically. This is what we are trying to see, right? So point B should be what? Point B should be the x value gets added up by delta x, right? So the original x value is 3, so it should be 3 plus delta x. And the y value should be delta y more than the original value of minus 1. So these are the coordinates for point B. And now, what is delta x and what is delta y? From slope we get it. We can say from slope that delta x is change in x value. This is delta x, right? Denominator. And delta y is the numerator. Correct? So from here, by comparing, what do we get? We get that delta x for us, change in x value is 4 and change in y value is 3. So if we add these values to original point, we get the point B, right? So what we are going to do here is, to get to point B, let me write like this. A is 3 minus 1. B should be, what should we do? We should add delta x value, which is 4 for us, and y value, change in y value, which is 3, to these values. If we do that, what do we get? 3 plus 4 is 7, and minus 1 plus 3, or 3 minus 1, is 2. We get the coordinates of point B, right? And therefore, our answer is, coordinates of point B are 7, 2. Well, we'll also like to verify it, correct? So let's verify. How can we verify? Let's use the standard slope formula, right? So let's use the formula to check. So let's check. Slope is change in y values, that is 2 minus minus 1. 2 minus minus 1. Change in x value, 7 minus 3. 7 minus 3. Now 2 minus minus 1 is 3 and 7 minus 3 is 4. Do you get the same answer? Yes, you do. So that confirms that our logic of getting point B is very correct. Now as an exercise, what you can do is, you can find another point B so that the line segment AB will still have the same slope, that is 3 over 4. How can you find the second point? You can find the second point by treating slope as minus 3 over minus 4. You get the point? So if you do negative 3 along the x-axis, you come here, right? And negative 4, you go there. So you get a point on the other side. Do you see that? So you get another point B, right? So that will be, your answer should be, take away 4 from 3, giving you minus 1. Take away 3 from minus 1, giving you minus 4. That should be your answer, right? Do it and then confirm. And for this, we have a practice question coming up, which you should do on your own. Thank you and all the best.